Alrighty, so this should be going on ISM page 59. This is the fundamental theorem of calculus. It might be helpful if you had your notes out from when we did Riemann sums so that we know how to explain the meaning of our answer. So get that handy. If you're actually putting stuff in your ISN, should be pretty easy to find. All right, so it says here, earlier in this unit we calculated Riemann sums in order to approximate. So remember, when we are calculating the Riemann sums, we're doing, remember when you see Riemann, that means rectangle. Okay, rectangle. In order to approximate the value of an integral. Below is a table that shows W prime of t, the rate that the water is flowing into a tank in gallons per minute, t minutes after a valve has been opened. Okay, so they give us this info here. We have this table. It says use right hand Riemann sums to approximate the integral from 1 to 15 of W prime of t dt and explain the meaning of your answer in the context of the problem using correct units. Okay, so one thing that this does not say that it would say on an official test or something, we want to use, it says we're going to use a right hand Riemann sum, so we are going to use 7 rectangles. Okay, so basically all the ones that we can use here. All right, so I'm not going to draw the entire picture, just going to draw a little kind of reminder of what's happening here. So here's my x and y axis. I have this function that looks like it's kind of going up and down, right? It's fluctuating. So I don't know, it looks something like this. I don't care, it doesn't really matter. And then I'm going to draw in just one random rectangle, okay? So I'm going to have some interval from here to here, okay? Now I know I'm actually going from 1 to 15, but let's just look at what's happening here. This says if I want to use a right-hand Riemann sum, if this is my interval, and since this is t, this is going to be my change in t here. That's what this is. This is my delta t. Right-hand Riemann sum means I use that right-hand side and draw to the left. So the base of my rectangle is the change in t. The height is whatever the height is on the right-hand side because it is a right-hand Riemann sum. So if I look at these little intervals I have, I'm going from 1 to 4, and then I'm going from 4 to 6, and then I'm going from 6 to 7, and then 7 to 8, and then 8 to 10, and then 10 to 12, and then 12 to 13. Now sometimes we skip over things like we combine them, but that gives us 1, 2, 3, 4, 5, 6, 7 little intervals, right? And so here are t values. But up here, I'm going to write my delta t. What is my change in t? So when I go from 1 to 4, the change in t is 3, because 4 minus 1 is 3. From 4 to 6, it's 2. From 6 to 7, it's 1, then 2, then 2, then 3. Okay? Those are my delta t's, basically the base of my rectangle. The height of my rectangle is my actual W prime of t value, if you recall that, but on the right-hand side. So if my interval goes from 1 to 4, then the right-hand side here, this is the number that I use. The right-hand side, this is the number that I use. Right-hand side, number that I use. Right-hand side, number that I use. I would say just circle them, just like this. Okay, so somebody knocked on my door, and I don't know what the last thing is that I said. But if you look at what I'm doing and the reason I'm circling it, this is my interval, right? And then this is what's on the right-hand side, because it's a right-hand side Riemann sum. So I've kind of connected all the things together. Because one thing that happens sometimes is that you use I'm going to use the 3 and the 3, right? Sometimes you use the 3, but then you accidentally use the 4, but that was the time. So you're changing time and then your W prime. If you just kind of connect them together, hopefully we can get the correct things going here. All right, so to write this out, I'm going to have, so the integral from 1 to 15 of w prime of t dt is about, okay, and then I'm going to have the area of each one of these right-hand rectangles. So a little bracket, the base, so I know the area of a rectangle is base times height. The base is the change in time, so that's my 3, times the height, which is your w prime of t, which is 3, plus 2 times 2. Even though you know 2 times 2 is 4, you do not put 4. You have to show addition and multiplication here. All right? So then let's go ahead and write out the rest of them. Plus 1 times 5, plus 1 times 3, plus 2 times 4, plus 2 times 6, plus 3 times 1. And then I want to put the brackets on there so I can put my units. So remember, I'm going to take, I'm multiplying these together. So I am multiplying gallons per minute times minutes. Those cancel out, and I'm left with gallons. So my units on this is gallons. Right? Now, for the purposes of what we are doing, we actually want the actual number. If I wasn't trying to connect something together, then I would want you to leave it like this. But we are going to continue on with this so that can bring something together here. All right, so that is going to equal, oh, what did I just do? Okay, well, hang on a second. All right, that equals 9 plus 4 plus 5 plus 3 plus 8 plus 12 plus 3. Okay, so 9 and 4 is 13, plus 5 is 18, plus 3 is 21. Make that 29. Make that 41, and 3, that is going to be 44 gallons. Okay, you don't want to risk adding or multiplying something simple wrong if you don't actually need the actual number. Remember, stopping here would be a safe stop, but again, we need to have that 44 number for the next part of what we do. All right, so then it says, explain the meaning of your answer in the context of the problem using correct units. Okay, so I have this 44 gallons, and I'll go ahead and use it, I'll go ahead and write it as if since we have something like 44 gallons, I can put that in the middle of a sentence. I wouldn't want to put this long nonsense here in the middle of a sentence. I wouldn't want to rewrite it, but I could say, blah, blah, blah is 44 gallons. So whatever we have, this is our answer. And the way we did it the other day is we said, this is, and then we went on. All right. Now that was on our Riemann sum stuff. So I want you to pause this video and I want you to see if you can write out the meaning of the answer in the context of the problem using correct units. Pause and then come back and I'll talk you through it. Okay. I'm going to trust that you paused even though I know some of you didn't. All right. So this is the approximate amount, because remember we are approximating, approximate amount, and I can just say amount because I should have gallons here or here, so there you go. This is the approximate amount of water. So I think this was a water problem again. Let's see. Yeah, so this was the rate that water is flowing into a tank. So this is the approximate amount of water that flowed into a tank now, and it says T minutes after the valve has been opened. So I don't really have to get into, that whole thing. But I do have to have an interval, and I can use T with my units. So I can say flowed into a tank from t equals, well, 1, that's where we get that 1 minute to t equals 15 minutes. Because remember, this is an accumulation, right? This is an accumulation over time. We're going from 1 to 15. This is not an instantaneous anything. When I take the derivative, that is a rate of change. It is an instantaneous rate of change. What's happening at t equals 5 or at t equals 3? This is not an at. This is a from, so it has to be an interval. Okay? We good on that? Okay, so that's a little bit of kind of like we've already talked about that, but we're looking at it again, and we're going to move forward and connect it with what's underneath here. So this was the rate. They gave us the rate. It was W prime of t gallons per minute. Okay, so now let's look at this chart. This next table shows the amount of water that is in the tank in gallons, t minutes after, so it's the W of t, the amount of water in the tank in gallons, t minutes after the valve has opened. So here's my t in minutes, here's my W of t in gallons. So this is the amount. Above there, that was the rate. So it says to evaluate the following and explain the meaning of each answer in the context of the problem using correct units. So W of 1. So this is W, t is 1, W of 1 equals 22. But not just 22, it equals 22 gallons. Okay, so what does that mean? That means at t equals 1 minute, and this is the amount that is in the tank, not the amount that is flowing in, but what is in the tank. At t equals 1 minute, there is 22 gallons of water in the tank. Okay. All right. W equals 15. All right. Well, W of 15 is right here. So that is equal to 66 gallons. And then in the text, in the context of the problem, that is the amount that is in the tank at that time. So that means I'm going to say the same thing, but I'm going to say it differently because you may write this differently. I could say that there is 66 gallons of water in the tank at t equals 15 minutes. Notice that I said the same thing in both of them. I mean, obviously one of them says 22. I mean, the numbers are different. But whether I start with the time or I start with the amount of water, and I'm not even consistent on when I do those types of things. So it's just kind of whatever makes the most sense to you at the time, as long as you have all the right. This time it is at t equals 1 and at t equals 15. Okay? And exactly how much is in there, not how much is flowing in, or it's not a rate. That's what is in there. Okay, so then we are supposed to find W of 15 minus W of 1. So that is going to equal 66 minus 22, and that is equal to 44 gallons. Okay. All right, so we took how much was in there at t equals 1, how much was in there at t equals 15, and we subtracted them. Okay? So that tells you when you subtract the two, you have an initial amount and you have a final amount. Well, your final amount minus your initial amount is going to be how much it changed, right? So I can say something to the effect of from t equals 1 minute to t equals 15 minutes, 44 gallons of water was added to the tank. And again, there's different ways to word that, but something to the effect of the amount of water changed by an additional 44 gallons or increased by 44 gallons. That might have been a good way to say it. From t equals 1 minute to t equals 15 minutes, the amount of water in the tank increased by 44 gallons. That's totally fine. Okay, either way. Or we could actually say flowed into the tank because that's what we knew happened, right? That's all, because that's what was happening there. Now, it says, what are some observations you notice about your answers? So, look at what we have here. Look at what we have here. See if you can see how this kind of connects together and why I wanted you to know that all this mess equals 44 gallons. Because where else do we see 44 gallons? Whew. Where else do we see 44 gallons? Right here, right? So this up here, this is what equals 44 gallons. And here, this is what equals 44 gallons. And in both cases, what makes sense is that that's the amount of water that was added to the tank or that flowed into the tank. Okay? So what we can get from this, we had a rate, we had a chart with rates, we had a chart with amounts. But we can see that if we take the accumulation, so what we had up there, the accumulation, so the integral from 1 to 15 of w prime of t dt, right? So that is the accumulation of water from 1 to 15 minutes. How much water flowed into the tank or was added to the tank. That is equal to the amount of water when t equals 15 minus the amount of water when t equals 1. So the change in water is equal to the final amount minus the initial amount. Okay? When you integrate, we're integrating a derivative. A derivative is a rate. So we're integrating this, but when we integrate it, we're not integrating it to an instantaneous anything. We are integrating it over a period of time, and so it is accumulation of something. In this case, it's an accumulation of water. It could be an accumulation of distance. It could be an accumulation of a lot of things. But when you integrate a derivative, so w prime, that's equal to, and then notice this 15 and this 1, this is where it comes from, right here. And this, ladies and gentlemen, is your introduction into the fundamental theorem of calculus, which is one of the most important discoveries mathematically. Let's see how this works. So taking this, okay, specifically with numbers that we just came from here, and here it is generically. So the integral from a to b, and notice this one's written a little bit differently. The way we've been writing them, instead of the a and b being on top and bottom, it's looked more like this, like out to the side of it. Both ways are acceptable. It's just two different ways to do literally the exact same thing, so it doesn't mean anything different. So the integral from a to b of f prime of x dx is equal to f of b, the final amount, minus the initial amount. So this is the amount of change. Well, I'm writing too big. Let's start over here. Amount of change that equals the final value minus the initial value. So it is relating our derivatives to our original functions, our integrals to our derivatives, and so forth. So a little something about notation here. If you were to Google fundamental theorem of calculus, or if you look in different textbooks or whatever, you could see, just like with any mathematical rule, you could see it maybe written a little bit differently. Doesn't mean it's really different. But one thing that you would see that might confuse you, because I think you understand here that we are integrating a derivative, and when we do that, we get, if I take f and I take the derivative, I get f prime. So when I go the other way, f prime gives me f. You could see it something like this. The integral from a to b of f of x dx, because I think we've actually, when we were talking about these, we were integrating f of x, and we were integrating g of x. So that's all fine and great. But when I integrate f prime, I get f. That makes sense. If I integrate f, what the heck do I get? Well, what you get is this. Capital F of b minus capital F of a. So when you look at a little chart of how derivatives work, we know that if we take f and we take the derivative, we get f prime. We take the derivative again, we get f double prime. So if I integrate f double prime, I get f prime. If I integrate f prime, I get f. If I get f and I integrate that, I get capital F. And notation is important, okay? Whether it's capital or lowercase, those things matter. Does not matter if you think it's cute to do it one way or the other. You've got to make sure that your notation is correct here. So now alternate forms, what that means is this. Maybe I'm not looking for the accumulation or the amount of change, and I'm just going to take final value minus initial value. Maybe I want the final value, or I want the initial value, and I have something else. So if I want, let's say that I want the final value. So my final value, which is f of b, okay, so if I take this equation here and I want to solve it for f of b, I can just add f of a to the other side. So the final value is equal to the initial value plus the amount of change. So it's good to understand what those mean so that when we try and put them together, you can get them in the right order and get them the correct subtraction. Well, let's say that I want the initial value. I want f of a. So from here, if I want f of a, I would add f of a over here and then subtract the change over here. So that would give me f of b minus, so the initial amount is the final amount minus the amount of change from a to b of f prime of x dx. Okay, so this, and this are all saying the same thing. We just have solved for a different one. Okay, so let's see how this works. Okay. We have this graph. Okay, and we're not estimating anything with Riemann sums. We're going to be able to find actual areas. We want to pay attention to the fact that this is f prime. You might even want, this is a graph of f prime. So we know what we're looking at, so we don't go doing weird things, right? So the graph of f prime above is continuous on the interval from -2 to 10. That's something they told us and something we can see. And consists of a semicircle and 4 line segments. So remember, when it tells you it's a semicircle or a quarter circle, that's important, especially if the scale's off and it doesn't look circular. And 4 line segments. It is known that f of 4 equals -3, and we want to find the following. Okay, I want to find f of 7. Well, f of 7, there's 7, and that's 0, but that's f prime, so that does not help me. Okay, I cannot integrate instantaneously, right? I can find an instantaneous rate of change. It doesn't work the same way going the opposite way. But I have to use something that I know. Okay, I know that f of 4 is equal to -3. They told me that right there. So if I can go from, on here, if I can go from 4 to 7, then that would be good. And I want to make sure that I'm going to the right so I don't have to worry about my signs and other weird things. So let's say I have f of 7, and that's equal to, so that's going to be my final value, minus, or equals my initial value. Okay, so final value would have to be initial value plus the amount of change that you have. A to b of f prime of x dx. Okay. Now, how did I know to use f of 4? Because that was the only information that I had. That's how I knew to use that. Okay. So my final value is equal to my initial value plus however much change happens. So then I know that f of 4, they told me it's -3. Plus, oh, look at me. I put a and b here. Of course I would mess. I've gone this far and didn't mess up on here. Boop, boop, boop. We know what a and b is, so we can put those in there. I'm going from 4 to 7. Okay. So I'm integrating from 4 to 7. I'm looking at this right here. Okay. This is what I want to find the area of. It is a trapezoid. If you want to split it into a rectangle or a square and a triangle, that is totally fine. When we do that, I think that's what most of you have been doing. So this is 2 times 2, so this is 4. And this is 1 times 2 divided by 2, which is 1. And it's all above the x-axis, so it's positive. So I get -3 plus 5. Now that is a safe stop. I can literally stop there, and that is my answer. I know you can combine those. Let's just stop there. Okay? All right, so then I have to find f of -2. Once again, not something that I can do just by picking a number off the graph or finding the slope, right? If this was a graph of f and I wanted f prime, I could find the slope at that point, but that's not what this is. We're going the opposite direction. So I have to use something that I know. I know two things now. I know f of 7, which is actually 2, and I know f of 4. Okay? I think it's safer to use what they gave you. That way you don't have to simplify this, and you don't have to worry about whether or not you simplified it right. So let's just use f of 4 again. So f of 4. So this time I'm going from -2 to 4. -2 to 4, right? Going in this direction. And so this is my initial amount, and this is my final amount, right? So this is I'm going to have to take the final and subtract the amount of change, going from -2 to 4 of f prime of x dx. Okay. So you want to say to yourself, initial has to be final minus however much the amount of change was. All right, so let's find this. F of 4 equals -3. They gave me that. And then I'm going to subtract from -2 to 4 is this right here. So that's going to be the area of the semicircle and the area of this triangle. Okay, so go ahead and calculate the area of the semicircle and the area of the triangle. Area of a circle is pi r squared. My radius is 2. I can see that here and here. So 2 squared is 4. That's the area of the entire circle, but this is only half of it. So it's not 4, it's 4 pi. So then the area is 2 pi. The area of this triangle, 2 times 2 is 4, divided by 2 is 2. So I'm going to subtract the amount of change, and this whole thing right here, this is 2 pi plus 2, and that's the best I can do, right? But when I subtract it right here, I have to make sure I put that in parentheses so that everything works out right. So I'm subtracting that whole thing. And then I don't have to simplify that at all. That is my answer. There's no units on this right now. So I want you to pause the video and I want you to find f of 10. And pause it for real this time, and then come back. Okay, so if you actually pause the video and try it on your own, then you can continue. If not, you need to call each other out and make each other pause the freaking video and work this problem out on your own. Hopefully by now, you've actually done that. So here we go. F of 10. So I have to use something that I know. So what I could do, all right, so maybe you used f of 10. And again, that's probably safest because of f of 10. You have to use f of 10. Oh my God. Maybe you used f of 4 because that's what we used on the other one. But remember, we could have used f of 7, right? And we know that this is actually 2. So I've debated whether or not, I've gone back and forth on whether or not I should do it this way or the other way. I'm guessing y'all probably used 4. And so if you actually did this and used 4, then we should get the same answer at the end. Let's see what happens. I'm going to use f of 7. You did not have to do that, okay? F of 4 is fine. Your work will look a little bit different, but we should have the same answer. And you can write this one down too if you want. This is a separate little way to do it. So this is equal to f, I'm going to have to use f of, I don't have to use, but I'm going to use f of 7, which is actually 2 here. All right. Well, I just realized I paused my video for a second. I've been teaching my little heart out over here, and I wasn't recording again. So I'm pretty sure that I erased up to where I stopped, but we'll see what happens. Because I did figure out where I stopped. And all right, I said at the end equals f of 7, and then I had to pause, and then I didn't hit record, and just kept teaching. So here we go. All right. Let me remember everything I just said here. So I have f of 7. And again, you're going to use f of 4. If you already did it, which I wanted you to already do it on your own, that's fine. You didn't do anything wrong. We're going to check our answers together in the end. So I'm going from, for mine, I'm going from 7 to 10. I'm going from 7 to 10, right? 7 to 10. Going this way. So that means that I want my final amount, which is my initial amount, plus the amount of change from 7 to 10. Of f prime of x dx. Okay, so I'm going to pause here for, I'm not literally going to pause my video, but I'm going to pause on working this out for just a second to tell you that when you set these up, okay, when you're using the fundamental theorem of calculus and you're not looking for the change, so it's f of b minus f of a, but you're looking for either f of a or f of b, notice that the only difference in what we've set up, besides the numbers in there, is that it's either a plus or a minus here. Okay? Now we've got a couple of options of how you can make sure that you get that part correct. One way is to always set it up like this and then solve for whatever it is you're actually solving for. That's one way to do it. And I almost taught it that way, but I decided not to. So here's the other way. I think the concept of initial and final you get. And as long as you understand which direction you're going, and always think about going left to right so that because you get to make that decision and you don't have to worry about weird signs. If I'm going from 4 to 7, then 7's my final amount. So the final amount is the initial plus the change. I think that should make sense to you. Then if I want the initial amount, it has to be the final minus the change, right? And I think that concept overall makes sense as long as you know what's what. Another way to either double check yourself or to think about it is if what you are looking for is on top, it's plus. If what you're looking for is on bottom, it's minus. Whatever works for you. Okay? All right, so let's continue this. So f of 7, now I'm hoping, since I'm actually using this and we got 2 there, I'm hoping that I'm right, pretty sure that I am, because that's the risk I'm running by using something I found instead of what they gave me. So 2 plus the amount of change from 7 to 10. So I'm integrating from 7 to 10, so I'll go back up here. From 7 to 10, I need the area of this triangle. So that is 1, 2, 3 times 1 divided by 2, which is 3 halves. So the area of the triangle is 3 halves. The integral is negative 3 halves because it is below the x-axis. So it is 2 plus a negative 3 halves, or I could have put 2 minus 3 halves, but I already put my plus sign, so we'll go with that. And this is a safe stop. And if you used 4 instead of f of 7, and you did a safe stop, your safe stop probably looks different than mine. But either way, and your safe stop was fine to do that, but to make sure that we actually have the same answer, go ahead and get past your safe stop. If I take 2 plus a negative 3 halves, I get 1/2. And so what you should get as your final value is, in fact, 1/2. If you did, that's great. And using f of 4 was just a different way to do it. And you might say, well, yeah, I defined more area. This, it was harder. This was easier. It's a matter of opinion, and it's a matter of what you see and what makes sense. And I'd have been wrong if my 2 was wrong. Well, of course, if my 2 was wrong and I used the wrong answer here, I wouldn't have gotten this credit, but I still would have gotten this credit. But then if you have to simplify things, sometimes it makes things weird because that's not the number you're supposed to get, and then it doesn't work out nicely. If you did not get 1/2, then pause the video and see if you can figure out why. Okay, so now you need your calculator because these are calculator questions here. We've got, from 0 to 10, we've got g prime of x equals this mess here. And it's known that g of 3 equals negative 12. We want to find g of 8. Okay? We are not going to integrate that and then find it and do all that stuff. We could do a general integral, but we're not doing that. We're going to use the fundamental theorem of calculus here. So I have g of 8. So g of 8 equals, I know it says fine, just pretend like that. And that's what we're doing, but I'm going to use that as part of my equation here. G of 8 is equal to g of 3. Okay, so let's think about how I said about the plus or minuses here. I know it's either going to be plus or minus, and I'm going to leave that blank for a minute. I'm going to go ahead and do my integral. I'm going from 3 to 8. Okay, since I'm going from 3 to 8, what I want is on top, so that makes it plus. Okay, now I have the integral. I could write all of this stuff right here, but they've named it. Okay, and College Board is very picky about things. They've named it g prime of x. Yes, I could write 1.3x times the natural log and blah, blah, blah. That's fine. But if I make a copy error and then I put it into the calculator correctly, then I'm going to have a problem with equality. So if they've named it g prime, I'm going to call it g prime of x, and I have to have a dx on there. You have to have that. They're looking for all these pieces. That is your setup for the calculator. Okay? So that's my setup. Here's what we're going to do. We're going to put all this in the calculator, and it's going to look like this. So I'm going to add it. We don't need to graph it. We just need the calculator right now. If you already added a graph, that's all fine and great. And so we said we have, what was it, g of 3, and g of 3 is negative 12. So, and that's okay. I don't have to write negative 12 here either because it's already defined. So it's fine. Obviously, in my calculator, I'm not writing g of 3. I'm using negative 12. So I'm going to put negative 12. Make sure you use the negative sign under the 3. Plus, and now I need an integral. There's 2 different places to find it. I'm going to show you both, and I guess you can decide what makes the most sense to you. One place you can find it is exactly where we found the derivatives. Remember we were finding the little derivative stuff right here? Mine's still highlighted. We're finding the derivatives. This right here, there's your integral. So if I click on that, that gives me the integral. I'll show you the other place to find it on the next question. I'll do it that way. So now for my integrals, I have to put in my limits of integration. We said we are going from 3 to 8, so 3 on the bottom, 8 on the top. And then in here, I'm actually typing that function. Putting g prime of x is not going to do me any good. So 1.3x times the natural log, which is under the e to the x, natural log of, and I'd like to have a fraction here, so control division. Numerator is x squared. Oh, lost my x squared. There we go. X squared plus 3x plus 7. Denominator would be x plus 1. So what I am integrating has x's in it. And so I have to make sure I put a dx over here. And then I hit enter. And it gives me my number. Okay, which gives me 64.7207. And we don't have any context here or units or anything. We're just understanding how this works. Okay? So let's see if you can set up the next one. Pause and see if you can set up the next one. Okay, I know most of you didn't pause, but whatever, I'm moving on. So I'm going to use something I know. This time I definitely don't want to use g of 8, even though I know it. I'm still going to use g of 3. So I'm going to have my g of 3 here. Okay? And I'm going to write my integral. I'm going to go from 0 to 3 because I want to go from least to greatest. Now what I'm looking for is on the bottom, so that's going to be minus. And then I'm going to have g prime of x dx. Okay? I'm going to put that into the calculator. And I'm going to show you the other place you can find the derivative or the integrals. Doesn't really matter either way, but I'm going to start with a negative 12 again, and then it's going to be minus this time. And the last time we went here and found it, and that works, but well, I don't know how to get out of it. Okay. You can go to menu. We're doing calculus. We're doing a numerical integral, and then it pops it in there. When you go through the menu, you have to know what it's called, right? And you might, but even if something popped in here and it didn't look right, you could get that. Here's another option you have, because look, let's think about what changed between these two questions. It's still g of 3, whatever that is. The plus and minus changed, and the limits of integration changed. But this nonsense that we typed in, that didn't change, right? So here's what I'm going to do. I'm actually going to delete all this out, because I would have just showed you this if I wasn't trying to show you the other place to find it. Let's say I just want to grab this so that I can edit it. Okay, so I'm here. I'm going to arrow up to where it's highlighted. Then I'm going to hit enter. Now it's here, and I can edit it. Edited it. So I can arrow over. All that stuff's the same, right? I need to change this. This is supposed to be a 0. And then this is supposed to be a 3. And this is supposed to be a minus. Now, the risk you run when you do that is not changing everything that needs to be changed, you know, so, I mean, it is what it is, but let me just, so I would double check. I got negative 12 minus, I'm going from 0 to 3, I typed my function incorrectly, everything looks good, and then I can hit enter. I get negative 22.2710. So negative 22.2710, I think. Once I click off, I forget what I did. Okay. All right. So I had to start a second video when I realized that I wasn't recording in the middle of the other one. So I don't know if I've gone way over class time or not, but you need to make sure you have actually finished this video and you have assignments in AP Classroom. Go do them. I'll see you Monday.